Good evening, everyone. Thanks for joining us for tonight's vBrownBag, and you're in for a treat. We have Tim Davis from VMware. He's going to be talking to us about NSX. He is the NSX Ninja and Sir VX Lancelot himself. So he's going to give us a little 101 overview of what is NSX, and he's going to talk about the components.
Is that my turn?
No,
Right.
I have to talk a little bit more. So if you want to interact with Tim, it's going to be a fun show. Join us on Twitter. We'll be monitoring the @vBrownBag handle, and also I'll be watching the hashtag #vBrownBag. Any questions, funny GIFs, or snide comments, please send them that way. You can see our worldwide show listings. There's a lot of good stuff going on, so please join in if you've got time. And with all that said, I'm going to introduce our special guest, Tim. Let me give you
Well, hey, how's it going? So, like you said, I'm an SE with VMware. Specifically, I'm a senior systems engineer for the NSX product working in the networking and security business unit. And I work with enterprise and enterprise select accounts in the TOLA territory, Texas, Oklahoma, Louisiana, Arkansas. Most likely, if you're on the vBrownBag, you've seen me running my mouth on Twitter. I also am a moderator on the Reddit VMware page. I'm one of 3 people who administrate the vExpert Slack, so I'm definitely around. Today we're going to be talking network virtualization with NSX. We're going to go over the 101, and we're going to go over the components, what they are and how they interact.
All right, Tim, I'll go ahead and make you presenter now. So.
Perfect.
I didn't want to catch you in the middle of that.
All right. So what can you see here?
It looks great. I see your slide deck.
Perfect. All right. So we'll kind of start off here with the 101 of understanding network virtualization. We'll kind of talk about what we're doing and how we're doing it. Go to my remote work. So network virtualization is kind of the core platform of the SDDC, or software-defined data center approach. And this is kind of an overall vision within VMware of what we think a great and efficient data center looks and runs like. And really what we mean with the SDDC approach is kind of abstracting all of your secret sauce, your agility and your speed and your functions, kind of decoupling from the hardware and bringing it up into the software space so that you're not dependent on a certain manufacturer, a certain series of hardware, whether that be compute, storage, networking, or anything like that. So let's kind of take a look at the data center as it exists today and kind of build up a little bit. You have your network layer. This can be leaf spine, this can be 3-tier, this could be Cisco, Brocade, Arista, really anything that you have in your data center today, as long as you're able to talk from point A to point B. This is kind of what we're working with. Connected to that, we have our compute infrastructure and also our storage infrastructure. So these are going to be your hosts, your storage, if you're using host with storage, really anything that's connecting through that's hosting your virtual machines. VMware has taken that compute layer and turned it into your hypervisor layer. So you've got your hypervisor, you've got your vSwitches and things like that. What we're doing with NSX is we're kind of building a platform on top of that that can be thought of as a network hypervisor. Now, that's not exactly what we have going, but that's kind of sort of what we're working and building and giving you. We're able to kind of give you the same services with networking and security as VMware gave you with the virtual machine. So for a while in deploying VMs and services into your infrastructure, you just had to go out, rack and stack a server, install an OS on it, cable it, give it an IP, give it some firewall rules and all that, and get your services off to the races. VMware went and took your compute infrastructure and turned it into a set of files. So you could create, you could delete, you could snapshot, you could migrate. All these things where you could deliver a server in 30 seconds with a click of a button, as opposed to racking and stacking and doing all this stuff. But the long pole in the tent with that, if you can use that verbiage, was still networking and security. So you still had to give it a VLAN. You still had to give it an IP address. You still had to create firewall policy for that. We go into customers today that are running, cloud management platforms like VRA, that they can deliver an entire application stack in the click of a button in less than a couple of minutes, but they still have to manually give it an IP. They still have to manually put in firewall policy. So we're kind of completing that piece of the deployment and letting you virtualize your networking and security services just like you do a virtual machine. So there's supposed to be sound, and I don't hear it. But this is just kind of a little video that shows you how it looks when you deploy a service with NSX. You're able to kind of select all of your different services, put them together, and it will also do all of your networking services at the same time. So you can go through and look and say that you're deploying a 3-tier app all at once. In vRealize Automation, this is going to be a multi-machine blueprint. So you can go through and say, I need a couple of virtual machines for web. I need one Tomcat VM for app. I need a MySQL server for database. I want those each to be on their own logical layer 2 segment. So that gives it each a layer 2 switch. I want all of those to be able to talk together. So you're going to give it a router, distributed logical router. Then you're also going to say, well, I need these to be load balanced on the web. I need them to have firewall policy A, B, and C. All of this can be put together and then put into a multi-machine blueprint where you're then cookie cuttering those out and can spin those out anytime somebody specifically asks for it, allowing you to speed up your deployment times rapidly. If you're in a heavy development shop, this is going to help out a whole lot because of the fact that rather than going and spinning up all these sandboxes left and right and destroying them whenever they're done, you can go through and say, well, I'm going to give them Portal. They're going to be able to click the button and make a sandbox. As soon as they're done, it's going to wipe it out. So now I can go off and do the important things instead of spinning up these dev environments all the time. So this is kind of a look at what one of those multi-machine blueprints kind of looks like. This isn't a direct view of that, but you can kind of see that you have 2 web VMs. Those are on a layer 3 subnet. Technically, those are layer 2 adjacent. You've got your app tier and your DB tier. All of those meet with a router device, and this one says NAT specifically. So we can actually provide overlapping IP spaces on the same hosts using NAT. We can also provide you load balancing services and all that kind of stuff right in the software. So in your data center environment today, you're actually already doing a little bit of virtual networking. There's a lot of people that think that when we acquired Nicira in 2013, we just slapped a label on their product and shipped it out as NSX, and that's really not the case. VMware's been in the virtual networking game for quite some time. Obviously, your ESXi servers and stuff have had virtual switches, but then also with the vCloud networking and security suite of products, as well as the vShield products, those are all what kind of came together with the stuff from Nicira to become NSX. So if you've got 2 virtual machines that are in the same host today, and they're layer 2 adjacent, your virtual switch is going to make that packet switch without having to hit the wire. It knows, hey, these VMs are on the same layer 2 segment. I'm going to forward it through. Leaving the host comes when you have to hit a layer 3 boundary. So you've got a couple of VMs that are on different layer 3 segments that are on the same host. So it's going to have to hairpin that traffic out, whether it be a top of rack device or an edge firewall or even a router somewhere in your environment. It has to go out to hit that layer 3 and then straight back. This causes a little bit of congestion and inefficiencies. Really, in the grand scheme of things, it's not a lot. Most people design their data centers today around that, but it's just kind of how things are going today. With a virtual network, we actually go into your distributed switch, which distributed switch is a requirement for NSX, and we install 3 VIBs into ESXi, and that's a VMware installation bundle. And we tell that virtual switch, well, while you already have that packet bus open and you're doing layer 2 checks, go ahead and check it for layer 3. We'll give you the access to the fire or the routing tables for that. We'll give you the control plane to be able to handle that. We also tell it, well, we also have a firewall that's stateful up to layer 4. Just go ahead and check it against that table while you're in there. There's been some people who have kind of come up and talked against NSX, saying that we're basically loading up your hosts with a bunch of overhead to do these checks. And really, even if you don't have NSX, you're already busting that packet open, the virtual switch. We're adding just a little bit more overhead to make layer 3 decisions, firewall decisions, and things like that. So now inside of your host, we're able to do switching, routing, firewall, and even load balancing right there in the host without having to hit that wire. Oops, sorry. So NSX is also meant to be programmatically provisioned, and really what that means is that we have an API that doesn't suck. There's been a lot of VMware products in the past that have not necessarily had the most graceful of APIs, if they've even had an API at all. Now, I will definitely say that with 6.5 and some of the newer products, we're working really diligently to kind of standardize the API game a little bit and to bring things up into the future. And with NSX, that was actually a big catalyst. NSX was built from the ground up to be utilized with an API. And we have a 400-page API guide, which if you're into that kind of thing is awesome. If you're not into that kind of thing, it'll put you to sleep real fast. It's rough, but you can do so many things with that API, so much so that one of our principal engineers for NSX will tell you that if you're using the graphical user interface for NSX, you're doing it wrong. Now, he's one of the biggest proponents for OpenStack that I've ever seen, so obviously he's going to be a real big proponent of the API. But really, utilizing NSX can be done in a multitude of different ways. You can use a cloud management platform like VRA or OpenStack. You can write your own Python scripts or PowerCLI scripts. We actually have a new set of commandlets for PowerCLI called PowerNSX that allows you to do the same kind of scripting you can with vSphere now with NSX components. But if you want to, you can also open up Postman and push a single API call to our open API. Or you can go into the UI and do it yourself. Really, there's lots of ways that we can allow you to deliver the networking and security services as fast as the vSphere admins can deliver a virtual machine.
Hey, Tim, quick question for you, man. So you mentioned VRA, you mentioned OpenStack, Open APIs. Is this VMware solutions only that can talk to the APIs, or can I use some other CMT if it's out of the space?
You can use absolutely anything that can push a RESTful API call with XML. Anything. You can make your own Python scripts. We've got customers that have their own cloud management platforms that just do VRO scripts and stuff in the background. Absolutely anything you can use to push a RESTful API call, you can do with NSX. So we kind of make it easy to automate your environment.
Awesome, thanks.
Yep. So we've got those 2 VMs, and they can now talk over layer 3 to each other in the same host. But we've also got 2 VMs that are on the same layer 2 segment that exist on different hosts. So let's say we're sitting in a data center and we've got a leaf spine architecture. And what that is you've brought layer 3 to the top of rack, and you're using equal cost multipath routing in order to go from rack to rack. So basically each rack might be its own subnet, and you're using routing all the way through the infrastructure. So how do we get 2 VMs in 2 different subnets to be layer 2 adjacent? Well, we do that with VXLAN. And what this is an encapsulation technology. This is an open standard. This is not some VMware thing that we worked on ourselves and that nobody else uses that's proprietary. This is a standard that's been worked on by Cisco, Brocade, Arista, I believe Juniper was also in that as well, VMware. So it's kind of a standard that everybody uses. Cisco actually uses a version of VXLAN in ACI. I believe it's IVXLAN. They just kind of took it and tweaked it a little bit for their devices. But we also have a bunch of hardware partners, including Cisco, that can talk our version of VXLAN. So if you've got these two VMs that are going from host to host over layer 3 boundaries but need to be layer 2 adjacent, then we take with NSX and we put what's called a VTEP, or a VXLAN tunnel endpoint, which is just basically a new VM kernel stack in all of your ESX hosts. And this does an encapsulation. So this actually brings up a requirement that we have in your physical underlay, which we don't have a lot, really just need to be able to talk from point A to point B. And we need a 1600 MTU or greater. And that's because we take the standard 1500 byte frame and we add a 50 byte header onto that for the encapsulation. An important thing to note here is that we do have the do not fragment bit flagged, so that if you have an MTU mismatch somewhere and any of the interfaces between those two hosts have 1500, it's going to drop that frame. We see a lot in our customers these days that are using like IP storage and things like that. They've already gone jumbo frames, so generally that's not a problem. But that is one thing to kind of keep in mind when you're designing a solution involving NSX.
And just in case, if somebody fat fingers and this is an MCU on the virtual or physical side, there's this thing called Network Insight that'll help you out.
So 2 weeks ago, Sean did Weekend at Bernie's, and we talked about vRealize Network Insight, which is the tool that we use for NSX for monitoring. And that will absolutely tell you that there's an MTU mismatch, and it will tell you why you're dropping VXLAN frames.
So, Tim, we do have a question that's come in from Graham.
Absolutely.
Can I run VXLAN on my network, then add NSX later?
So can you run VXLAN on your network now? And that's actually a great question. If you're using, say, for instance, ACI for your underlay, that does VXLAN encapsulation. With our encapsulation, you can absolutely add that in later. It will do double encapsulation. The only thing you would need to worry about at that time is your MTU. So not only are you adding the header for the encapsulation that you already had, you'll need enough room to add the NSX header later. So you absolutely can do double encapsulation. We have lots of customers that are doing that in production today, even if they don't necessarily know it or planned for that. That's just kind of how it's worked out in their environment. So the one good thing with VXLAN when it comes to encapsulation is that the VMs have no idea they were encapsulated. All of that is done at the VTEP on the egress of the host or the ingress of the destination host. So when the VMs send their layer 2 stuff out, it gets encapsulated, it gets sent over the wire, and that is just an IP UDP frame. And then it just gets decapsulated at the other side and sent up to the other VM as layer 2. They have no idea this is happening. Now, we get a lot of things when we say IP UDP, where people say, well, hey, this is going to break TCP. Really, it's not. So the difference between TCP and UDP, TCP is acknowledged. So if something gets dropped, it gets retransmitted. With UDP, it doesn't. It just gets sent on and drops. So if you encapsulate a TCP packet in a UDP packet and send it across, the UDP is going to break and drop, but the TCP will not have been acknowledged on the other side, so it'll get retransmitted. So we do have ways of working around that. Native isolation. So I talked about a little bit ago how we can have overlapping IP spaces. This is extremely important to a lot of our customers. There was a very, very large transportation company that I worked with very recently, and one of their biggest use cases was consolidation. So they used HPC 7000 chassis, and they kind of had one for dev, one for staging, one for prod and QA and all that. And they kind of were having problems where if they were running into congestion in one environment, they couldn't just simply move resources over or move that workload over. With NSX, they're going to use our distributed firewall as well as our virtual networking in order to consolidate all of those environments so that they can pool all of their resources together for better utilization. So support for physical workloads. We've got a lot of customers that are not 100% virtualized, and we can absolutely provide a software VTEP for that through our Edge Services Gateway, which allows us to do a VLAN to VXLAN bridge and give you layer 2 adjacency even over layer 3. Obviously, these days, 1 or 2 layer 3 hops is not really a big deal. So we definitely recommend you do that if you can, but if it absolutely has to be layer 2 adjacent, then we can definitely work with you. We've also got some hardware partners like Dell, Brocade, Juniper, Arista that do hardware VTEP, which basically brings the control plane from NSX into that physical device, allowing you to do the VLAN to VXLAN bridging with a top of rack switch. We've got a lot of customers that hear that and they say, great, we need that. Brocade for a while with their smart fabric was going around and telling people, you're doing NSX? Awesome, we integrate, put top hardware VTEP everywhere. I think maybe 1% of the customer use cases that have been interested in hardware VTEP, it was actually necessary. So you really have to work with your SE and see if that's for you. Most of the time, it's just not necessary. We can do it with software. So non-disrupted deployments, this just kind of shows the hairpinning that we're doing for layer 3 in the same host, layer 3 in different host. This is the same thing for our security. So if you're doing east-west security today and you're hairpinning your traffic to a physical firewall, we can take that off since we're doing firewalling in kernel now, and you're not having to hairpin that traffic out. So a use case of SDDC, data center network security. In the past, we've kind of shoveled all of our cache into perimeter firewalls, which was great when our traffic flows were really heavy north-south. So we had a lot of customers that were coming into the data center, they were going down the stack and out the stack, and then heading out of the data center. With virtualization, that traffic pattern has shifted very heavily to east-west instead of north-south. So nowadays, we've got people who have these data centers that have these giant steel irons at the perimeter and absolutely nothing in the center. My best analogy for that's Target. So when Target got breached, they hired a penetration testing company who came in and started working, and by the end of their time there, they came back and handed them their PII database. And they were actually able to get that by coming in and finding a device, I believe it was a Deli meat scanner, that was running Windows. And they were able to use that to infiltrate the network and then move laterally until they found what they were looking for. So with devices these days, lots of end user devices, and of course the biggest security risk ever of people. It's just one of those things where you really need to kind of protect your east-west traffic a lot more than you used to. It's great. We never suggest that you get rid of your north-south firewalls at the perimeter. Just kind of take a look internally as well. So our approach, or our, I guess, term of the week for this is micro segmentation. There's lots of companies that have done words like micro segmentation. I've heard macro segmentation. I even heard the joke of pico segmentation once. And a lot of people mean that as different things. Some people mean that as using VLANs all over the place. There's one vendor that uses PVLANs and top of rack ACLs all over the place. Ours means one thing and one thing only, and that is putting a firewall bubble around every single one of your VMs, running right at the VNIC. So if you think of your VMs as a physical server plugged into a physical switch, our VM sits right on that wire between the VM and the virtual switch. We use a technology called DB filter groups. There's 16 of them. The first 4 are reserved for ESXi and the last 4 are reserved. We kind of set up right there in the middle of that. And we also use something called service chaining, where we can use our firewall and then we can put in partners such as like Palo Alto or Checkpoint, McAfee for IDS IPS, and we can kind of put those in a row so that all of your traffic that's coming out of the VM can get checked by our firewall. If you need it deep inspected, we can redirect it to Palo Alto. If you need it IDS IPS, we can redirect it to their service VM. and kind of work to get you the security you need. And all of this is done in kernel at memory speed. So you're not having to hairpin that traffic out either to a virtual machine or to a physical device. And this just kind of shows that. So defining security policies. We have ways of building security policy based on a lot of different context. We'll get into this, I think, in 2 weeks when I do the distributed firewall portion. But really, we're able to build policy since we're connected to vCenter, not just on IPs, like a whole thing of 50 to 100,000 lines of 5-tuple IP scheme. We can actually connect through and read VMware tools and say, I know what OS this is running. I know what the VM name is. So you can build policy based on VMs that are named web dash or VMs that are running Windows Server 2003 and create a policy based on that. We can also log all of this. We have integrations with, of course, our Log Insight product. We can also dump that syslog out to a SIM if you have one in your environment. We have lots of ways of working with that. We have tons of customers that are passing PCI audits today using nothing but our distributed firewall. We've got tons of customers doing HIPAA with our firewall. We actually have a template for the Epic application, which if you work in healthcare, you know what a beast that can be. There's a couple of the guys in the NSBU that are absolute rock stars. Jeff Wilmington, if you're out there, he's the big one on that. Go and harass him about Epic. They'll tell you all about it. So we're definitely taking over in the industry in terms of security. People are starting to, look at us and say, hey, they're not necessarily dumb. They know what they're doing. We've also got, I think it's 5 DoD sticks for implementing NSX. That's a really, really big deal if you're really heavy into compliance. So if we look at physical firewalls and virtual firewalls, we're kind of distributing the technology, and we're turning all of your ESXi hosts into a firewall. If you've got 2 10-gig NICs in there, we're going to be running at just about 20 gigs, just under line rate for your firewall. We are scale out in that regard. So instead of taking your east-west traffic, if you have 100 gigs and you go up to 120 gigs, you don't need to go out and buy a bigger firewall with a bigger interface in order to firewall that traffic. You can scale out your hosts and kind of distribute that load. We're also only firewall checking the VMs that are on that host at that specific time. So you're not firewalling 100% of your traffic on each host at 100% of the time. You're only checking the VMs that are there that the policy applies to. So we're able to be a lot more efficient with our firewalling as opposed to taking all the traffic and just punting it out to a physical device. I just heard mute on. Can you hear me?
Yeah, I can hear you.
Okay, I guess I just heard it muted me. Okay, so this is kind of a look at our distributed firewalling performance on a 20 gig host with 0 filters. You're running just under line rate. And you can kind of see that when you start adding on our firewall rules, it really drops it just a little bit. And I know that these numbers don't do justice. If you're interested, we can definitely get you our high performance scale numbers. I know we've got one of our PMs that works really hard at making sure that all of our scale numbers and our performance numbers are kind of up to date. We have a whole range of things that we can do for really, really high throughput and high performance options. Getting certain NIC cards that do VXLAN offload, turning things on like large receive offload and receive side scaling. We can kind of bump those numbers up. We also have the ability to do multiple VTEPs per host if you're pushing the limit of your one NIC. So we can kind of work and push that performance through the roof while still making everything distributed so that you're not hairpinning all that traffic out. So this is just kind of a look, 80,000 connections per second with 100 plus rules per host. There's a typical virtual appliance for firewalling. We'll do about 6,000 connections per VM. And a physical appliance will, of course, do like 300 to 400,000 per VM, but you're also hairpinning all that traffic out to check it. So native security capabilities. We're hypervisor based. We're not going through and we're not throwing out this service VM. We're not hairpinning all the traffic to it. We're running everything right in the kernel natively on your ESXi host. We're also giving you the ability to automate your security policy with APIs or even things like dynamic security groups, where you can say, no matter what, any VM that has web dash in it gets the web policy. So you can create and delete VMs all day long, and they'll automatically have that policy. So looking at here, we have no isolation, segmentation isolation, and then service insertion. The service insertion is what we mean when we're talking about adding in our distributed firewall and then chaining in things like a Palo Alto or a Checkpoint or anything like that. So this is just kind of shows you how the advanced service insertion works. I really don't like this slide because it has Panorama connected to the NSX Controller, which it doesn't. That actually should be the NSX Manager. So when you create and you connect Panorama, which is Palo Alto's management platform, when you connect it to NSX, it automatically goes out from NSX and deploys a service VM on every single one of your hosts. So we're able to take that traffic and redirect it in kernel to their service module in order to do their layer 7 deep inspection and all the cool stuff that Palo Alto does. You are also now, as a version 8, able to create rules in the distributed firewall from Panorama without having to go into our firewall. So you can create those redirect policies natively. And of course, with Panorama, you can also do your physical firewalls from the same device. So now, if you're using a third-party integration like Panorama, you're able to take advantage of all of the in-kernel stuff that we're doing with NSX, but also using the same tool that you've been making firewall policy with forever to make these new policies. And I hate this slide. Just kind of shows you distributing your workloads everywhere and having your policy follow it. So of course, since we have policy that's wrapped around the VM itself, whenever that VM migrates, that policy migrates with it. And that's from host to host, from cluster to cluster, from vCenter to vCenter in a multi-vCenter environment. That policy can follow that VM no matter where it goes. So why looking at it as a best approach? If you're looking at some of the most efficient data centers on the planet, your Googles, your Amazons, your Facebooks, when you go into Amazon, you create a new VPC and you start creating all these services, there's not a guy that's going back in the closet and moving, switch cords around and stuff like that and creating all this stuff for you. All that's done in software, which is why developers and things like that are flocking to them, because of the fact that they're able to click a button and get what they want. Now, when it comes to compliance and things like that, as well as costing, you don't necessarily want them running off and doing the shadow IT thing in Amazon. Now, you can, of course, give them the ability to go to Amazon, or you can do it in your own data center. So we can kind of give you the same abilities that you could with Amazon. Now you can have it on-prem. And we can give you those services like firewalling, load balancing, L2 and L3, all with the click of a button right into your SDDC platform.
And not to go into a rabbit hole here, but I do want to mention for the team's sake, Tim is talking specifically about SDDC environments, VMware environments, and really calling out really the questions our customers and concerns our customers have had in the Azures and the AWS space and Google Compute and so on. But one thing to note, and we announced it, we actually showed it last year at VMworld, and it's actually the team that I'm a part of now. We're actually going to extend the NSX functions to an Amazon and to an Azure and those types of things. And so remember, this is focused on the private cloud, and we want to continue that fashion, but we have a plan moving forward for native AWS and those types of things. So cheap, that's just a little cheap infomercial, but I do think it's pertinent to know.
And you're hearing that straight from the mouth of the new guy that does cross-cloud services. So of course he wants to push that heavily. So everybody keep your eyes open.
No, seriously, I plead the fifth. No, we showed it last year at VMworld, and we got a lot of things that are coming for our customers this year. And really the key here is the foundational layer is NSX. And I think that's what you're going to see from us moving forward.
And that's one thing that A lot of people that know VMware know that just like any other company, we want you to use VMware. We absolutely want you to use VMware everything all the time. It's great. Use it. Buy it. But you're going to get a little bit different message from the networking and security business unit. I have to kind of put my hand up and pretend like I'm not talking near my core account reps when I'm talking to customers, because from the NSX side, we know that our customers necessarily aren't going to shy away from public cloud. They're going to look there. You're most likely, if you're signing an ELA with Microsoft, they're throwing Azure credits at you faster than you can stock them. You've got developers that are going out to Amazon, whether you know it or not. So we know that this is going to happen. We know you're looking in this direction. We know that CIOs have gone out golfing with their buddies and heard the word cloudy cloud, and they have to go there. So as an NSX person, we want you to be able to leverage those kind of utilities, but still keep the same networking and security platform that you have across the board. So we've got another product called the NSX Transformers that allows you to do multi-hypervisor, including not just vSphere, but KVM. We've got working with Amazon, obviously, and we're also working towards possibly working in Azure. So it's one of those things where we know you're going to go that direction, but we want to make sure that everything is secure and stable across the board. So NSX will obviously come up in any conversation with VMware when it comes to multi-platform services. Now, this next slide that I have here, I've had it sitting for a little bit. It's just kind of a look at our partner ecosystem, and this slide is actually out of date because we've got some other stuff in here. This just kind of shows who we're working with. Now, we're not going to come into the industry doing networking and security and say, well, we're obviously going to be better than Palo Alto. We're going to do load balancing better than F5. No, we're not going to do that. We don't have the time or the experience for that. But what we can do is say, well, we'll give you a connection to our kernel and allow you to do what you do best, directly integrated with our platform. So most likely you have these kind of tools in your environment, and we give you the ability to kind of connect and extend those and still use the same NSX platform, but then get your layer 7 inspection from Palo Alto, your super crazy iRules from F5 and stuff like that. Is this the end of my slide deck for this one? Yeah, all right. One sec. Now we're going to switch gears to the component overview here.
Tim, I do have one question while you're kind of getting that.
Yes, sir.
And let me know if you are going to get into this, but let's say I've got existing VLANs with subnets and I'm going to implement NSX. Would I have to get all new subnets provisioned out for that, or would I be able to?
Absolutely not. So that's one of the things where with NSX, we allow you to kind of simplify your underlay. We work really well with customers that have a segmentation push where they're going out and VLANing everything everywhere. We've got greenfield deployment guides with little to no VLANs, and we've got brownfield deployment guides. We help to kind of minimize that segmentation push with VLANs, so you can absolutely utilize the VLANs that you use today, or you can migrate that infrastructure into VXLANs. NSX is kind of a suite of products, so you can use just our network virtualization, or you can use just the firewall, or you can use both. We're really not going to dictate that you have to use all or nothing. And that's one great thing with our distributed firewall product. It's probably 60% of our users at this point went with NSX just for that product. And that has none of those physical underlay requirements like the MTU size and any of that. Doesn't encapsulate, doesn't do any of that. You can just drop distributed firewall on your existing VLANs and start making policy today. Did that answer your question?
Yeah, perfectly. Thank you.
Perfect. All right. So we're going to switch gears here into the component overview section. And I'm a little behind on that last one, so I'm going to go a little faster here. But no worries, we'll get there. Whoop, if it'll let me. Okay. So the vSphere components, we're going to kind of build here. I know some people don't like build slides, but I really like this one. We have our consumption plane, and this is really going to be anything. How do you access NSX? As we talked about before, that could be cloud management platform, that could be the graphical user interface, that could be command line. Lots of different ways to consume the platform. Connected to that, we have our management plane. This is going to be your standard vCenter server. Then we also have the NSX Manager now. Now, the NSX Manager is connected one-to-one with vCenter server. There is no caveat to that. There is no one-to-many or many-to-one. They are just flat out one-to-one NSX Manager with vCenter server. So we also have in our management plane our message bus, and this is our internal communication channel. So our awesome open API is available from the consumption plane to the management plane. So when you're pushing API calls, you're doing that directly to NSX Manager. Anything from the NSX Manager down is a closed, secured API. You don't have access to it. You don't have the ability to get into it. You won't really have the need to do that at all. All of that is self-secured, self-signed, and all that. So you can do all of your API calls externally, but you won't be able to get into it internally. Moving down to the control plane, and this is really the bread and butter that we got from the Nicira acquisition. The control plane is what allows us to do network virtualization without requiring PIM multicast routing on the underlay. So we're able to do it in what we call a unicast mode, which we'll get into next week in the switching and routing segments. But really, if you thought that we just kind of bought Nicira and slapped a label and called it NSX, this is really what we got from them. Now in the control plane, we also have our logical router control VMs. And this is for our distributed logical router that lives in all of our ESXi hosts. Now, none of this for the control plane is in the data path. So you're not actually passing traffic through these at all. The user world agents that's here for your control plane, this is just part of our internal communication path from the NSX Manager down. It's kind of what does the puppet mastering between NSX Manager and your ESXi hosts. So moving down, this is where we have the data plane. This is where the actual data traverses. Now, I really, truly hate these slides that say NSX vSwitch because it makes it sound like we have some kind of like different switch, and we really don't. When you ever see or hear NSX vSwitch, all that means is the virtual distributed switch that you know and love today with the VIBs from NSX. And really, that's just our kind of beefed up VDS. You cannot do NSX with standard switch. And obviously, you can't use the Nexus 1000V. That's going away. So is the IBM one and the HPE one. Those are going bye-bye as well. You probably saw that announcement here recently. So in our data plane, you have the ESXi hosts. That's got your VDS with the VIBs, and also our NSX Edge services gateways. Now, these are virtual appliances that get spun out into your environment. Those are in the data path. That is kind of a hang up for some people that we've got virtual machines in a data path, but really you're not passing necessarily all of your traffic through that depending on how you have everything set up. Most likely as an ingress and egress point you are, but these things are 10 gigabit throughput, and we can scale those with an active standby pair or even up to 8 of them aggregating 80 gig throughput in an equal cost multipath fashion. So the NSX Manager, as we said, it's mapped one-to-one with vCenter Server. This is where you're going to see that new tab in vCenter for networking and security. This is where you're going to do all of the initial configuration as well as all of your day-to-day operations unless you're utilizing it with an API. This is the only virtual appliance that you will actually go out to vCenter and say, file, deploy, template. Once you do that and it's connected through to the API of vCenter, all of the little sub things like the controllers, the control VM, and the Edge Services Gateway, all of those are templates that exist inside of the NSX Manager. They get deployed automatically depending on what settings you pick. So the NSX controllers, these are kind of the brains of the operation when it comes to the virtual networking piece. You don't need these at all if you're only doing distributed firewall. These provide the control plane for distributing network information to your ESXi hosts. So they're holding on to your forwarding tables. They're holding on to your VTEP tables. So when you've got a VM that reaches out and says, hey, I need to contact another VM, and it sends an ARP out, that ARP is actually answered by the NSX controllers. Now, before these control plane was in, if you were using like vCloud networking and security, you were needing multicast in order to take care of answering that. But with us, we're sending out basically a bunch of unicasts in order to take care of that. Now, the NSX controller has a bunch of different roles. It handles a lot of API stuff handled by NSX Manager. It handles all of your switching and routing tables and things like that. And it also handles a lot of your configuration information, and it holds the active state of the environment. Now, all of your controllers, which we recommend 3, and really that's not a minimum recommendation or anything, just 3. They're set up in a way and they're developed in a way that you can do 1 for a completely non-prod home lab type environment, but as soon as you deploy 2, you have to deploy 3. They're just consider it a triplet. And that's whether you have 5 hosts or 5,000 hosts in 8 different vCenters. You only need 3. Since they're not in the data path or anything like that, they're perfectly sized to be able to handle even the largest of environments in a 3-pack. Now, these things are in a control or in a cluster, and they do have masters, but it's not what you would typically think of where one controller is the master. Since there's a bunch of different roles, there could be a different controller that's a different master for a different role at any given time. This master election process is done under the hood. You don't really have to go in and mess with it. You don't have to set anything up or anything like that. Now, each role requires that there be a master controller. Any of those controllers, as I said, can be a controller at any time. So let's say we have one fail. The master election process between the other 2 automatically happens. You don't have to go in and set anything up. You don't have to make any API calls. It just happens for you. When the 3rd controller comes back, it rebalances all of its roles. So if we've got a bunch of objects in our environment, a bunch of logical switches, logical routers, and objects and things like that, how do we kind of evenly distribute all those services across your controllers to make sure that one of them is not overloaded? The answer that we came up with was slicing for that. And what that's saying is that if we have a whole bunch of different slices for these services, like a bunch of different logical switches and logical routers, we're going to kind of pepper these slices throughout the controller clusters so that they're evenly distributed. Since each one is a different master for a different role, it's also going to have a bunch of different slices on it. Now, let's say we have a failure of control 3. Just like the master re-election, we're also going to take and redistribute those slices so that everything's even. And as soon as that control node comes back on, everything is going to rebalance. So our controllers, when you deploy them, they're automatically sized. They're all 4 vCPU and 4 gigs of RAM each. Modifying those settings is not supported. You will not gain or lose anything by changing these. Well, you can lose something by changing it down, but you're not going to gain anything performance-wise by scaling these up at all. The controller password is defined during your first deployment. This is actually a real strong password. I think it's like 12 characters. If you ever do the hands-on labs for NSX, you'll notice that it's the same default password just done twice. As soon as you set that password the first time, every subsequent controller deployment is going to automatically take that password so that you don't have to do it again. Now, controller nodes do have to be deployed under the same vCenter server that NSX Manager is connected to. That doesn't necessarily have to be the same vCenter that you've got all of your NSX stuff working in, but the controllers do have to be in the same vCenter where NSX Manager is connected. The NSX Manager itself could be hosted off in a management vCenter elsewhere. With these, since there are 3 nodes, we do recommend that go into your vSphere management cluster. And we do recommend that you manually put anti-affinity rules to make sure that those 3 controllers stay on different hosts all at the same time. That way, if you lose a host, you're not necessarily losing your entire control plane. So the user world agent here, this is kind of our internal communication channel. It is secured and it runs as the net CPA agent on all of your hosts. This is what allows NSX to kind of communicate through the stack. Now here's that NSX vSwitch term that I hate again. Again, this is just your distributed switch with the VIBs that we've got. So the logical router control VM. Now, this is absolutely not in the data path. When you deploy a distributed logical router, which is our router that runs in kernel of all of your hosts, if you're going to be doing dynamic routing like OSPF or BGP, you have to have a static point to peer to. You can't peer to a IP address that exists on all of these different hosts at the same time. So we deploy that logical router control VM. If you're just going to be doing static routing in and out of your environment, you don't even have to deploy this. It's actually just a checkbox when you're creating a distributed logical router. Now, the Edge Services Gateway is absolutely in the data path, and that does our layer 3 through layer 7 services. So when I talked about earlier about doing overlapping IP addresses on hosts, that NSX Edge Services Gateway is where that NATing is going to happen to make that work. That's also our peer from your physical interfaces or from your physical routing devices downstream into NSX. Edge Services Gateway will always be the ingress and egress point. You could technically peer a distributed logical router straight to a physical device, but we don't recommend that in the architecture. So component interactions. The management plane talks to control plane, talks to data plane. This is just kind of a look at the one-time versus recurring tasks with NSX. Deploying NSX Manager in the controller cluster is going to be a one-time thing. It's actually pretty quick. Host preparation, this is where we go out and actually install those installation bundles. Now, this is going to be a no reboot process for that. And up until version 6.3 of NSX, updating or removing the VIBs did require a reboot. But as of 6.3 and up, that does not require a reboot. So we can do updates and stuff like that non-disruptively from 6.3 on. Logical network preparation, so doing the VTEPs and stuff on the hosts, that's definitely going to be a one-time thing. Once you get that set up, you're good to go. The recurring tasks are going to be basically the same tasks that you do every day today in your environment. Creating new VLANs, or in our term, VXLAN or VNIs. Creating new routing devices, routing interfaces, creating networks and network services. All of these things that you do on a recurring basis, you're still going to do in NSX. We're just going to give you a new tool to do it in, or even automate that task so that you're not having to sit there and cut VLANs all day long.
Hey Tim, since you're
yes.
there and you're talking networking, who owns NSX in your customers? Is it the network team? Is it the VMware team? Is it a new team?
So that's a fantastic question. We've had a lot of networking vendors that in the beginning of NSX would come in and tell their networking engineers that VMware is going to come in and take away the job of the network engineer and give it to the VMware guy. And that's simply not the case. I illustrate that in my meetings by looking at the VMware guy and asking him how to troubleshoot OSPF or BGP. 9 times out of 10, they'll glaze over and wonder, what you're asking them. Network guys still do network things. Security guys still do security things. It's just a different interface, or even not even an interface if they're using automation. So really, it's one of those things where if you're, say, moving from Cisco IOS to NXOS, and you're going to have to learn something new anyways, why not use our tool and stick with the older physical devices and use virtual networking overlays to do all the new fun stuff? It's just one of those things where you definitely, absolutely have to have network guys still. You have to have security guys still. That's never going to change. It's just where they're going to make the changes that they need. So configuration from, So configuration from a component interaction standpoint, I know we're running close here. The NSX Manager talks directly one-to-one with vCenter. When you make a change to your virtual network, it's going to talk to the control cluster. The control cluster is then going to push the information out to all of your ESXi hosts. It's going to work as the puppet master. The difference is going to be is when you have something like just a distributed firewall. Since we don't require that controller cluster, that communication goes straight from NSX Manager to your ESXi hosts. And that's across however many clusters you may have. Control plane security, obviously, I said this is a closed API. This is a closed communication channel. It uses self-signed certificates. You do not have the ability to go in and change that. You can't use your own certificate infrastructure. We take care of all of it. You won't have a need to or anything like that. Now, I really hate this slide because it has the NSX Manager as kind of a adjacency to NSX Manager. You don't have the ability to get that. It doesn't require a SQL server or anything like that. It's embedded into NSX Manager. You won't have access to it. You don't need to offload it somewhere, nor do you have the option during installation to offload it somewhere. So I really don't like that it illustrates it that way. But really, the NSX Manager goes into its database and does the certificate generation, and then passes it down to the control clusters, and then also passes it down to the ESXi hosts. It does this communication all through our user world agents and our message bus, and that's how it kind of sets up that closed communication loop between all the components. Now, looks like we've come through to the end of the components as well as the 101. Do we have any other questions or anything that we're hanging around?
I've seen a few come through saying, how can I get my hands on this?
That's a great question. So up until recently, we were pretty tight with NSX. You had to contact your SE in order to get your hands on it. You can go into Hands-On Labs today and play with it. I believe it's Hands-On Labs 1703 and 1724. The 1703 will be the basic. I think it's split up into 3 different groups for networking and security. And then 1725 or 24, whichever one it is going to be your multi-site and multi-vCenter NSX. You can also, of course, contact your SE and get a POC in your environment if you feel so inclined. Or the big new thing is you can go sign up for vMug Advantage, which I believe is $200 at this point, and you will get just about every piece of software VMware makes, including now NSX. So if you want it in your home lab, which is really awesome to play with, and I'm staring at a giant rack of gear as we speak that I got started on with NSX, that's a really a great way to get your hands on it. That'll come through with your vCenter licensing, your vSphere licensing, the NSX licensing, and the whole works for you to kind of get your hands dirty and play with it.
Awesome. Thanks for answering that. I put out on Twitter the hands-on lab numbers you said. So they better be right, because I just quoted you on those. So
I think it's 25.
Another question about licensing is, does part of this come with vSphere Enterprise Plus licensing for the host?
So licensing is completely separate for NSX. NSX is not in a bundle. It doesn't come with anything. Enterprise Plus does have your virtual distributed switch, which is required for NSX. But a cool thing is that if you get NSX, no matter what licensing you have for vSphere, we will give you distributed switch. I believe there's some smaller essentials kits for vSphere that don't come with distributed switch. So if you were to say attach an NSX license to that, distributed switch would turn on for that. But as far as suites or anything like that, NSX does have 3 tiers of licensing, but they are all separate SKUs. We have standard, which is just network virtualization, so your VXLAN switching and routing and stuff like that. Advanced is where you enable the distributed firewall. And then Enterprise Edition is where you're going to get into the multi-vCenter or multi-site.
So there was a vShield component that came with Enterprise Plus. Is that separate, not something that's consumed by NSX?
Yeah. So vShield, which used to be used for agentless antivirus, that has been deprecated, and there's now NSX Manager, and you were absolutely right. I completely forgot. NSX Manager is available for agentless antivirus for free, just like vShield was. And that's specifically going to be the guest introspection that's used for that. So if you have a vCenter license today, you can go and download NSX Manager, but unless you were to give it a full license, you're not going to be able to do any of the really cool stuff with it. But you can absolutely use it today for agentless antivirus that you were using vShield for before.
All right, so that's all the questions that I've seen come through. Yeah, I guess we can call it a wrap. Thank you so much for all that great information. I'm that VMware guy who's kind of got drool on the side of his mouth whenever you asked about those acronyms. I'm not even going to pretend to say.
OSPF and BGP, which are in fact the two dynamic routing protocols that we support with NSX.
Great. Well, thank you very much, Tim. We
Absolutely.
really appreciate it, and we're looking forward to the next 2 weeks.
Sounds great. Next week we're going to be doing virtual or logical switching and logical routing. So that should be where we get into the really cool stuff networking wise.
Awesome. Well, we'll see you then.
All right. Sounds good. Thank you.